Okay, we'll start with the trigonometric identities. Here's what we call the Euler identity, right? E to the ix. If you take the imaginary power of the exponential function, the natural number e, then you get these imaginary numbers as the output. There's actually a graphical representation of this, which is that if x is the angle, then, and this length is 1, this point here is cosine x plus I sine x on the complex plane. So we all know that the complex plane is made up of the real line and the imaginary line. And knowing this, we can talk about the following identity, which says e to the IA times e to the IB equals to e to the IA plus B, right? Simply because the exponential functions add up. The exponents add up when we have the same base. Now let's see what the left side is and what the right side is using this identity here. The first thing is you have cosine of A plus I times sine of A. And e to the IB, if I use this formula again, it'll be cosine of B plus I times sine of B. And on the right side, if you look at this and compare it with this formula here, it's like x being replaced by a plus b, right? So I can rewrite the right side as a plus b plus I times sine a plus b. Now let's multiply the left side out by FOIL. So cosine A times cosine B plus I times cosine A sine B plus I times sine A cosine B. And then the last one, if you do I times I, that's I squared. What's I squared?
Negative 1.
Negative 1, so it's negative of sine A sine B. So that's the left side. Let's try to simplify this by collecting the real part and the imaginary part. See, these two have I attached, so those are imaginary parts. These two are real parts. So I'm going to put them together. Cosine A cosine B minus sine A sine B plus I times, let me write this first. That's the usual format, sine A cosine B plus cosine A sine B. So we just worked on the left side and simplified the left side. And this left side should equal to the right side, which is this. If you compare the right side and the left side, you can see that the real part on the right side is cosine A plus B. That doesn't, that's the one that doesn't have the I attached to the real part. The one that has I attached is the imaginary part. The real part is cosine A plus B, whereas the real part here is cosine A cosine B minus sine A sine B. And if you look at the imaginary part here, that's the same as the imaginary part here. So we get a nice equivalence, which is that the cosine of A plus B is equal to cosine A cosine B minus sine A sine B. And also, if you have sine A plus B, that's sine A cosine B plus cosine A sine B. Now these two formulas are called angle sum formulas. Now from these two, many useful formulas come up. The ones that you already know of when you're using it for Calc 3 was the following. If you have A and B equal to each other here, you get cosine of A plus A is 2A, right? And that gives you cosine A times cosine A, which is cosine squared A, minus sine A times sine A, which is sine squared A. And then using that sine squared of A is 1 minus cosine squared of A. If you use this and replace that, negative of negative is positive cosine squared, so cosine squared plus cosine squared gives you 2 cosine squared of A, and then minus 1. So that's what you get. And also you can do the opposite. You can use cosine squared is 1 minus sine squared, then apply it here. It will give you 1 minus 2 sine squared of A. And if you take this identity and solve for cosine squared, this is what you get. If you add 1 to both sides, which is 2 cosine squared of A, and divide both sides by 2, you get cosine squared of A equals the cosine of 2A plus 1. And you can also solve this equal to that for sine squared, and the result is that you get 1 minus cosine 2A over 2 equals to sine squared of A. Okay, so we put a lot of formulas up here. And the ones that you really need to know are this one, and these two. And to show you the purpose of this, I will give you an example. You'll soon have to calculate lots of integrals involving trigs. So suppose you had to integrate sine squared of x dx from 0 to pi. How would you do this? You will be using the fact that sine squared of A is 1 minus cosine 2A over 2. So you rewrite it as 0 to pi, 1 minus cosine 2x over 2 dx. Because 1/2 can be pulled out, you can pull that out. And then integrating 1 gives you x. What's the integral of cosine? Integral of cosine is sine. So what's the integral of cosine 2x? 1/2 sine 2x. Right? So 1/2 sine 2x. That's the integral, and you plug in 0 and pi. In both cases, if you plug into sine, you get 0, right? This one, you get 1/2 of pi. When you plug in 0, you get 0. So 1/2 pi is your answer for the integral of sine squared. And by the way, this will be one of the integrals that we'll be doing frequently. Okay. Now, in addition to this, you need to know that sine of negative x is negative sine x, whereas cosine of negative x is positive cosine x. So you can, if you just want to summarize what we're doing so far, you only need to write these two, and these two. Okay, just six equations so far. Okay? And in this on this, I'll add a few more. But I'll tell you every time when we reach to the important ones. Okay. All right. So what is this saying? See, sine graph has the following property. If you draw the sine graph from negative pi to pi, that's the graph of sine of x. And whenever you evaluate at some negative of x and compare the value of x, you can see that basically sine of x and sine negative x are exactly the same but with opposite sign. That's what this is saying, right? Now, if you have such a graph where you have a graph where one side goes up, the other side goes down, if one side goes up, the opposite side goes up, that's called an odd function. So, this note sine x is an odd function. While cosine of x is an even function. An even function, let me first explain it to you by drawing a graph. If you drew the cosine from negative pi to pi, the graph will be like this. This will be on one side, the other side will be like this, from negative pi to pi. That's the cosine graph. Now, this graph has the property that if you folded it along the y-axis, the left and right matches, right? Yeah. In that case, you say, because it evenly matches, you call it an even function, okay? And that's why, since this is like the opposite of being even, that's why this is called an odd function, okay? All right, so what does that mean? Well, that can be, these two properties, that sine is odd and cosine is even, can be used along with these to give you another pair of formulas that look similar to this. So instead of having the sums, we can write down the ones with the minus. So for example, cosine of a minus b. What would that be? Well, see, that's like replacing all the b by negative b, right? If you took this and replace your b by negative b, you get this one. So on here, you should do the same. You should replace the b by negative b. But what's cosine negative b?
Cosine b.
It's same as cosine b, so that doesn't change. What about sine negative b?
Negative sine b.
Negative sine b, so the sign does change. So in this case, this will be plus. And then for sine of a minus b, will this one change sign? See, b is replaced by negative b, so you're plugging in negative b into cosine. What happens? Sign changes or not? No. No change. Okay, so that doesn't change. How about this one? Replacing b by negative b does change the sign. So you have these four sum and difference formulas. You also have this is actually called the half angle formula, because traditionally this formula was used to find out the cosine of half angle. So if a was 15 degrees, that's half of 30 degrees. So you let a as 15, and your cosine of 30 degrees plus 1 over 2, which is cosine squared of 15 degrees. And because we did know what cosine of 30 degrees is, it's right equal to 3 over 2. You can solve this for cosine 15 degrees to get the exact value of cosine 15. You can also do the same for this one. You can use this to find the exact value of sine 15. So that was traditionally the reason why people were using it. Okay. Next thing I want to say is the final formula that we need to know is product to sum formulas. And it goes like this. If you had sine A times cosine of B, if you have sine A times cosine of B, then you can rewrite this as half of sine A cosine B sine A cosine B and then I add and subtract these, cosine A sine B. So I'm going to put plus cosine A sine B minus cosine A sine B. Are they equal? You see that this is same as this? First, these two cancel. These two double. But because of that 1/2, you end up with the left side, right? Now, I mean, this is not what you want to get at. You want to actually remember the next line. But my suggestion is actually try to follow this process every time you have to remember this. Okay? So, if you have sine A times cosine B, what do? You first write it as sine A times cosine B, sine A times cosine B. You add this cosine A sine B and subtract it. Because this much is equal to what? What is this equal to? No, this plus this equal to what?
Sine A minus A plus B.
This formula, right? What about this? Sine A minus B. Okay, what about cosine A cosine B? Oh, again, do the same trick. You just double it, meaning that you're allowed to write it twice. So I doubled it, but took a 1/2, so that you can come back to the original one. And then this time subtract what? This one. And then plus add sine A sine B. Because that's going to give you what? 1/2 of
Cosine A plus B.
cosine A plus B. And plus cosine A minus B. And what you're doing is effectively changing product of two cosines into addition of two other cosines. Here we're changing product of a sine and a cosine as sum of two sine functions. Okay, furthermore, you can do sine A sine B. Actually, this is slightly more complicated. What you want to do is you want to do this minus this. You want to do cosine A plus B minus cosine A
Plus B.
minus B. Now, if you do that, what do you get if you do this minus this? What do you get if you do this minus this?
0.
This cancels, but what about this? This minus this. Negative 2 sine A sine B, right? But I want just sine A sine B, not negative 2 sine A sine B. So what do we do?
1/2.
Negative 1/2, because we want positive. So those are the formulas. Of course, you don't need to know the derivation of each, but it's really helpful if you know the derivation. You don't have to memorize if you can derive. Derivation is just one line, so it's really easy to remember. Okay. All right. So let me show you the purpose of those formulas. So here's an example. What's the integral of sine of x times sine of 3x? Oh, by the way, usually in the textbooks, people also write cosine A times sine B, but that's redundant because if you have cosine 30 degrees times sine 15 degrees, for example, you can switch them around, right? And make the sign go first because multiplication is commutative. So you don't need a separate formula for cosine A times sine A. Just switch them and just rename them. Okay, so that there's no need for the fourth one. Okay, so you only need these three. Okay, so for example, I needed the integral of sine x times sine 3x. How would you do this? You apply the formula that we just have over there, which is negative 1/2 of what? Cosine of x plus 3x minus cosine of x minus 3x. Okay, that's what it says, right? Okay, negative 1/2, we can pull it outside. Cosine of x plus 3x is 4x. Okay, what about this? X minus 3x, negative 2x, but this negative is not needed. Why? Because cosine is an even function, so if you have a minus, you can just delete it. Okay? All right, now you can integrate both of them. Cosine integrates to sine, positive sine, and you have to put what? 1/4. Okay. How about this one? 1/2 sine 2x. So when you multiply these out, the final outcome is 1/8 of sine 4x, and then plus 1/4 of sine 2x plus c. So that's how you integrate this product. Some of you may have seen this in Calc 2, but I doubt it. Most of you this will be your first time seeing such a thing. No, the red button.